Praveen sir, can we start the session now?
Yes, please.
Yeah, so before handing over to you, I'll just give the introduction about the expert, about Praveen Kolle sir. Praveen Kolle is the superintending engineer at Water Resource Department, Government of Maharashtra, India. Presently, he is working at Pune Irrigation Project Circle, Pune, handling the responsibility of construction of water and irrigation infrastructure, including dams, canals, pipe network, small hydropower schemes, etc. He is pursuing PhD at IIT Bombay as external candidate. In fact, we both are pursuing PhD under the same guide. Prior to that, he worked as an executive engineer at Pune Irrigation Division, handling the responsibility of water and irrigation management activities. Previously, he held the position of executive engineer and assistant executive engineer after securing the first rank in WRD in Maharashtra Engineering Service Examination 2004 conducted by MPSC. Prior to that, Mr. Praveen Kolle secured gold medal from Pune University for being ranker in civil engineering in 2004, and then he completed MTech from IIT Kanpur in 2007. Later in 2014, he completed IIM Indore's executive postgraduate program in e-governance. He also completed MBA in finance, also Master of Arts in Public Administration, and hold 3 postgraduate diplomas as well. Mr. Praveen Kolle is honored with several awards, including Outstanding Engineers Awards by Government of Maharashtra in 2019 for his work in irrigation management. In 2019, on behalf of WRD, he received Geospatial Excellence Award for application of drone in water management. His participation in Integrated State Water Plan was appreciated by Director General Mary. He also received Sir Visvesvaraya Award by hands of Principal Secretary, Government of Maharashtra in 2011. He is a life member of 13 technical and scientific organizations, and he is a speaker at conferences including India Water Week. He has also delivered guest lectures at various institutes in India. He has designed, hosted, and managed his own website, that is www.praveenkolle.com, where civil engineering study material is made available to the students. There are many things to tell about Mr. Praveen Kolle, so you can even visit his website. Okay, so now I request, without wasting much of the time, to deliver a talk on urban flood management using IoT. Thank you.
Yeah, thank you, Sagar sir, and welcome friends. Today we will discuss about the urban flood management and how we can explore Internet of Things for better management of the flood and better urban management. So, Sagar sir, can you give me access for the presenting my presentation?
Yes, yes, sir. Just a minute. Yes, I have made you presenter now.
Yeah, yeah, thank you. So, is my presentation visible?
Yes, sir, it's visible.
Yeah, yeah, great. Yeah, so friends, today we will discuss about urban flood management with the help of IoT. And in this presentation, we will discuss basically four aspects. First, in the first part, we will discuss about the disaster, and one of the bigger disaster is that is a flood. So we will discuss what is disaster and what consequences it brings and what are the effects of floods. Then we will discuss about the urban flooding. In the next part, we will discuss how Internet of Things will help the flood management. And in the last part, we'll discuss flood management and way ahead. So we will start with our discussion with the disaster. So disaster. So in India, there is an act known as a Disaster Management Act 2005. So as per this act, disaster is defined as it is a catastrophe or a mishap or a calamity or a grave occurrence. So it is an extreme event in any area arising from natural or man-made cause or by accident or negligence. So disaster can occur from man-made reason or maybe because of the natural consequences. And this disaster is occurring because of the reason that because of any reason, and this disaster should result in a substantial loss of life or human suffering, and it can also bring damage, destruction of property, or degradation of environment, and is of such a nature or magnitude as to be beyond the coping capacity of the community of the affected area. So this is a very elaborate and very precise definition of disaster. And in short, we can summarize this disaster definition as: disaster is a unwelcomed incident, and which is an extreme event, which can be a man-made or can be a natural phenomena, and this brings a huge loss to the life, property, or environment. So after understanding disaster, let's classify the disaster. So as we discussed, disasters are classified into two parts. First is a natural disaster, and such as volcanic eruptions, earthquake, floods, etc. And second type is a man-made disaster. For example, wars, chemical oil spill, global warming are the man-made, man-induced disasters. So first, in order to manage a disaster properly, we need to understand the disaster risk, what risk it brings with it. So disaster risk is composed of three factors. First is a hazard, second is exposure, and third is a vulnerability. So in order to manage a disaster efficiently, we need to understand these three terms, and IoT will help in order to capture the information with regards to all these three terms. So we'll discuss this in detail. So what is hazard? Hazard is a potentially destructive physical phenomena. Then, for example, earthquake or flood is a hazard, so which has a potential, and it is a physical phenomena, and it can bring a disaster in a given area. Then what is the exposure? Exposure means the location, attributes, and the value of asset that are important to the communities. So if a city is residing or a city is organized nearby the river area, then there is a hazard potential and city might be exposed to the flood. So exposure is also important condition for the disaster risk mitigation, and it includes people, ecology, and infrastructure. And last term is a most important, which is a vulnerability. Vulnerability is the likelihood that asset will be damaged or destroyed or affected when it is exposed to the hazard. So every event or every disaster has a probability of occurrence. For a flood, for earthquake, there is a certain probability of occurrence. So if that event occurs, it can damage entire location or entire city, and that's if such city is situated at such a vulnerable location, then it has a more chances of destruction. So and if we club all these three factors, we can say that, for example, a flood hazard can be treated as an urban population residing at a low-lying area near river, and which this river can be subject to intense rainfall causing a flood. So if all these three factors come together, then disaster happens. So as far as IoT is concerned, for assessing the hazard potential, we use IoT assessment of the hazard potential and its monitoring. Second, for measuring the exposure, we use tools of GIS and remote sensing in order to map the exposure conditions, land use, land cover, river topography. We map and monitor these exposure conditions. And third is a vulnerability. In this, we model this phenomena. We try to model the natural or man-made phenomena, and we try to analyze the things. So all these three important functions, the IoT helps a lot. So why India is vulnerable to the disaster? Number one, 57% of the India's land is vulnerable to earthquake, and out of this 57% land, 12% is vulnerable to severe earthquakes. So there are chances of severe earthquakes on about 12% of the land. 68% of India's land is vulnerable to the drought and 12% land is vulnerable to flood. So these two are droughts and floods are two water induced or water related disasters, and and you can see that the potential of drought is much more than the floods, but the loss of life due to the floods is much higher than the droughts. And 8% land is vulnerable to cyclones. So after having a brief discussion about the disaster, we will discuss the floods. So what is a flood? We will in this presentation we will discuss the various important things in a detail. So this flood word came from Old English, which is the old word was flood or plu, and it was having Indo-European language root. And for last 10 years, the flood was the about the 80% of the natural disaster. It contributes 80% of the natural disasters. If you count the disasters of the last 10 years, then floods contributed 80% in that disaster. And these disasters are caused because of the floods, droughts, and severe storms. And flood frequency and its intensity is increasing day by day, and it is in future also it is expected that the intensity of flooding and frequency of flood occurrence will be more because of the adverse impact of the climate change. And if we see worldwide database, then worldwide 2 billion peoples are affected during last 20 years. So you can realize that it has a big potential of destruction, and this is a natural event. So this, in order to mitigate and manage this flood event, we require tools and techniques for better management. So what tools are really helpful for the flood management? So we will discuss very briefly in this slide, and then we will discuss about the flood. So first tool is required in order to capture the weather information. So in order to get warning or forecast of the flood, it is necessary to get the idea about the weather. So if there will be an intense rainfall, or if there will be a cyclone, this information can be obtained from the automatic weather stations. So AWS are installed at the remote place, and generally automatic weather station capture the information such as rainfall, sunshine intensity, wind speed, temperature, humidity, and there are other parameters which will be captured by the automatic weather station, and these parameters are stored, and these AWS are powered by the solar panel, and it also has a satellite antenna. So using satellite signal, the stored information is communicated to the main server, and there are several AWS specification which provides the supply of such type of data at interval of 15 minutes. So at every 15 minutes, we get the weather parameter database. So if we install such AWS across our country or our state, then we will get idea about the how weather is behaving. So in order to capture weather information, we use tools of IoT. Then second important function of IoT is to record the dam levels. So in a state like Maharashtra, there are several dams. There are large dams, and it is utmost important to know the water level in the dam. So in order to know the water levels, there are dam level recorders. Using these recorders, again water level is fetched, and based on the water level uh, there is a table which gives the storage in the reservoirs. So using this database, we can conclude we get a real-time information about the dam level, storages available in the dam. Third is a river level recorders. So after getting dam data, weather data, third important aspect of field database is a river discharges. So river discharge is calculated using river level recorders, and such very compact and real time such river level recorders are installed over the bridge, and these river level recorders collect the information of the water level in the river, and this level is also communicated to the main server at interval of 15 minutes. And in order to communicate this information to the server, we can use a satellite network or a GSM network, wherever it is a feasible. So there is a important role of the communication system. So there is a communication between the weather station or dam level record or sensors installed at the dam location or the river location, and this data is communicated from the source to the server. And once this data is received, there are some models, and using internal models, we get the output, and this output is again needs to be communicated to the stakeholders. So citizens can be a stakeholder, other departments can be stakeholder, police administration can be a stakeholder. So communication is very important in flood management, and IoT helps uh, to fulfill that role. Another important tool is a GIS. So using GIS, the land, watershed, habitation, the river system is monitored. So we can segregate the real world information into various GIS layers, and using this layer, we can have a prediction. So we can better visualize the our analysis. We can get the transportation layer, we can have water feature layer, we can have the digital elevation model, so that we can plan evacuation or emergency action plan very effectively. Then another tool is helpful in flood mitigation is modeling for flood prediction. So using various sensor, we get the information about the rainfall, runoff, and dam levels. And if there is anticipation that there will be a flood, or generally flood is a increased discharge in the river. So if we get a warning that there will be a flooding in the river, so we can anticipate that which area will be inundated and what will be the consequences. So if we know advance warning, so we can plan evacuation, we can we can make the alternate arrangement for the evacuating people and make communication plans much more effective. The another important aspect of the IoT is dissemination of the information. So once uh, decision maker or policy maker or the flood manager has a information about the flooding, so this information needs to be communicated to the each and every individual. So for communication of this information to IoT tools are very useful. And last but not least, in order to make evacuation plan, if there is a flooding, then which population should be evacuated, where this population should be transported, which route should it take, how for how many days they will reside there, how to organize their living things. So all these three things can be modeled or can be planned using GIS and other tools. So we can realize that there are tools of IoT, and when these tools are very useful, integration of various tools of IoT, these tools are very useful for flood management. So in the upcoming slide, we will discuss how flood is different than the other disasters. So first, their difference is that floods generally affect wider geographical area as compared to other disasters, except earthquakes. So the destructive spatial resolution of the flood, the spatial resolution of the destruction will be much more in case of flood. Second, there will be the direct losses as well as there will be indirect losses. So in the one of the slide, we will discuss what are the indirect losses and what are the direct losses of the flood. And many a times indirect losses are much higher than the direct losses. The flood causes the deformation of land, and it also causes destruction to the infrastructure, which result in these infrastructure and land becomes unusable or unsuitable for the regular use. So this is a big disadvantage, because if infrastructure is not available for emergency action plan or for taking a corrective course in order to mitigate the flood, then it becomes a challenge over challenge. So flood brings it flood causes a start of consequential disasters. So flood alter the courses of river. Sometimes the if volume the discharge in the river is very high, then it can cause a alteration of the course of river. It can disturb public transport. It can demolish public infrastructure, and it can cause a loss of agriculture over a larger area. There can be a blockages or damages to the roads, bridges and other infrastructure, which makes access and communication difficult. So in order to, when there will be a disaster, the access and communication is important in order to have a proper evacuation strategy. But because of flooding, this basic need gets hampered, and that's why the disaster mitigation becomes difficult. Electricity supply and supply of clean drinking water is interrupted in the flooded area. So these are the basic needs of human being, and if these needs are disrupted, then mitigation becomes much more difficult. And generally floods also brings landslides, and because soil gets saturated, and if landslides occurs, then intensity of disaster also increases. The flooding can be caused by the either fresh water or by the salt water, and depending on which water brings the flooding, the its impact are different. For example, if there is a flood because of the fresh water, this fresh water carries suspended solids which leave the mud and soil behind. So because of the sedimentation of the sedimentation of the solids, the ground becomes muddy, and it causes other health issues and consequences. And if salt water, if flood is caused because of the seawater entering in the land area, then this salt water makes water sources unsuitable, and it can also cause a salinity of the soil. So what are the damages caused because of the flood? So this data shows the damages due to the flood from 1953 to 2015. So total area affected during this period was 442 million hectares. And if we average out these numbers, so annually 7 million hectare area was affected, and maximum damage occurred in the year 1978, and in that year 18 million hectare area was affected. So total affected population during this period was 198 million, and average is the 3 million, but maximum affected population was 7 million, and that was in year 1978. And there was also damage to the crop, and this, if we convert these damages in terms of rupees, then these damages are 2,93,000 crores. So it is a huge damage for the society. And also it caused damages to the houses, cattle, human lives, and which cannot be, we cannot calculate these damages in terms of money. So there are direct damages and there are indirect damages. So who is responsible for the flood? So there is a debate across the world. Is flood is an act of God? That is flood is caused by the natural reason, or it is an act of human? And there is a no straightforward answer. It depends on the perspective and the incident in which we are debating. So since ancient period, when there was no development, there are incidents of flood, but its impact has been magnified because of the human activities such as deforestation, global warming, encroachment in the river portion, and the damages to the natural drainage system. So because of the urbanization, we flatten the slopes, we cut the trees, and our rivers gets encroached, and many drainage system we lost it. So because of this impact, the intensity of flooding has been magnified. And there is a theory which says that Indus Valley civilization lost because of the flood. So in a nutshell, we can say that flood is an act of God, because flood is generally occurring because of the intense rainfall occurring on a very short time, but its intensity gets magnified because of the act of human. And in this research, which was carried out in 2004 by the Dartmouth Flood Observatory, it has been observed that the maximum number of flooding occurred because of the heavy rain. The second is the brief torrential rain, then tropical cyclone, monsoonal rains, snow melt, and one of the factor which contributed flood is the failure of dam or embankment. And there are also reasons such as tidal surge, avalanche related, etc. But most of the time flooding occurred because of the heavy rain. And there are events, there are these are the reported events across the globe. And if you can see that in India there are more than 60 events for this last 40 years period. There are about more than 60 events. So at least there is a one event. If we average this number, there is a one or more than one events in a year in our country. So the Internet of Things helps to collect and share the information related to flood, and we can better, if we this information is available with us, we can collaborate with the other countries. We can go through the best practices, the success stories of the flood mitigation, and we can prepare a flood mitigation plan for a given basin. So in order to mitigate flood properly, we need to understand its the types of floods. So basically there are four types of flood. So first type of flood is a river flood. We will discuss these types in upcoming slides. Second is a flood caused because of the sustained rainfall. Third is a coastal flood, and fourth is the flash flood. So what is the difference between these four? We will discuss now. River flood, it is very easy to understand. Generally, most of the habitation occurred on the bank of river, and if there is intense rainfall on the upstream side of that city or habitation, then if that the rainfall brings runoff, and if that runoff is more than the discharge carrying capacity of the river, then the water flowing in the river gets out of the bank, and it enters in the habitated area. So because of this, some area gets flooded, and this basically happens only because of two reasons. First is a rainfall, intense rainfall, or because of the slow melt, which is not a common reason in our part. Except in Himalayan part, India does not witness the flooding because of the snow melt. But in the southern part, like Maharashtra and other parts, they mainly flooding occurs because of the rain. And this is the one of first reason. And second is the carrying capacity of river to carry out this flood water is less, is a second reason. And these two things are predictable. For example, using IoT, we can have a real-time information about the rainfall. So what rainfall is falling on the ground at us on a upstream side, on a catchment side, we can get this information. Using modeling tools, we can predict that how much water will be converted into runoff, because whatever amount of water falling through rainfall will not be contributed into runoff, because there will be losses like infiltration, evapotranspiration, and there are other losses. So the whatever component is available in a river stream is known as a runoff, and this runoff we can anticipate if we have proper rainfall runoff relationship and rainfall value. Second is the flow capacity of the rivers. So using tools of GIS, we can analyze what is the capacity of this river in order to surpass the flood. And using these two information and tools and techniques, we can make advanced flood warning system and a technology based evacuation plan. And we can, if this plan is available, and if we know that there will be a specific area which will go under flooding every year, then in that case we can have floodline regulation. So as a development authority, the local administration will say that there will be no development zone beyond this line. So some part of the river stretch will be kept as a reserved portion for the carrying out the flood water, so that this water will not be stuck because of the development happen in the river portion. And this floodline regulation helps to maintain the river stretch encroachment free. Second type of flood is a sustained rainfall flood. So suppose there is a no river adjoining habitation, but there is an intense rainfall happening over a specific land, or cloud burst is happening at specific location. So in this case, if rainfall duration is larger, then this brings a flooding at a particular location. And this sustained rainfall flooding occurs at a flat terrain where drainage is a problem. So particularly, for example, in Pune city or Mumbai city or Chennai city, if there is an intense rainfall within a city boundary, then if the drainage system is improper, or there is a the storm discharges are very high as compared to the drainage capacity, then it causes a flooding in a city, and it is very difficult to tackle. Third type is a coastal flood. So the cities which are surrounding or adjoining to the sea, there is a possibility of coastal flooding. And the ocean is very vast, which covers about 72% of the Earth's surface. And if we see the world population, about 10% of world population lives in the coastal area, which is just 10 meters above the sea level. So this is very vulnerable location for coastal flood point of view. And about 40% of the world population live within 100 kilometers of the coast. Coastal flooding occurs when dry and low-lying land is submerged by the seawater or the floodwater. And coastal flooding cause significant biodiversity loss and potentially extinction of the some species. And if there is a prolonged inundation of seawater on the soil, then it can cause a soil salinity, and this will result in the lowering of the agricultural productivity. Thus, this flooding will cause a temporary damages, as well as it will cause a long lasting damages, such as the loss of productivity of the soil. The coastal flood is very sensitive, and the intergovernmental panel on climate change predicted that the global mean sea level will rise from 9 will rise by 9 to 88 centimeter from the period 1990 to 2000 2100. So during this period, so there will be increase in the sea water level because of the global warming, and this will cause increased intensity and frequency of storm events such as hurricanes due to the climate change. Thus, in future, coastal flooding from storm surges will become more frequent with sea level rise. And there is another concern. There is a chances of damage due to the tsunami waves. So tsunami wave cause intense damage, and these are caused due to the displacement of the significant body of the water, which is caused because of the earthquake, landslides, volcanic eruption, or glacier calvings in the sea. And because of this, the tsunami happens, and destruction is happen because of the two reasons. First, velocity of the approaching wave. Because of the higher speed, it crashes on the structures or infrastructure, and it causes destruction. And second, if height of tsunami wave is more, then it can damage a larger area. And third issue is tsunami waves brings debris with it, and if this debris enters in a habitation area over the land, it can cause a further damages. So after understanding the coastal flood, now we will discuss the flash flood. So flash flood, as name suggests, it is a rapid flooding of an area by rapid rainfall. Flash flood characterized by the time scale of the fewer less than the 6 hours. So if flood happens for within a period of 6 hours, then it is known as a flash flooding, and it is generally caused by the heavy rain associated with the severe thunderstorm or hurricane or tropical storm. And it can also occur because of the glacial lake outburst flood. It can be caused because of the natural ice or debris floating in the water or human structure such as a man-made dam. And this cause huge loss. There is a less time for evacuation and there is a less scope for the regulation. So advanced warning of the flash flood is a prime important, and IoT will help the administration as well as the society at large in order to mitigate the adverse impact of the flash flood. So how to measure flood? So in order to manage the flood, it is necessary to measure the flood, because it has been said that if you can't measure it, you can't manage it. So in order to manage it properly, we need to measure. But how to measure a flood? Unlike earthquake or hurricanes, flood do not have a standardized rating system that we can use to measure the intensity of the flood. So there is a no standard unit. However, there are three factors which decide the magnitude of the flood. So which are these three factors? First factor is stage, that is depth of water or in a river or in a flowing stream. So this is a most important factor. So if a river carrying a flood, if water level rises, that means it will have a higher magnitude flood. Second factor is a discharge. Discharge is a volume of water passing in an area in a certain period is a discharge. And third is a area under water, that is a inundated area. So these three factors, we can uh, make a combination of these three factors in order to assess the severity of the flood. So size of the flood is measured on a recurrence interval system. So how frequently flood occurs, that is also important. And if the probability of occurrence of flood in 100 years, if the flood occurs at every 10 years period, then it is known as a 10-year flood. So if 10-year flood occurs, it does not mean that at every 10 years it will happen, but during the last 10 years there is a higher probability that such intensity flood will occur. Second flood is a 25-year flood. Third is a 100-year flood. And larger the flood interval, bigger is the flood. Also, this Dartmouth Flood Observatory also classified flood into three classes. Class 1, large flood events. So they classified these events in which the flood which cause a damage to structure or agriculture and which generally occurs within 1 or 2 decades. So a flood occurring having a return period of 20 years is known as a large flood event. They classified flood as a very large event as a class 1.5. So in this class they classified all the floods which as here, and in the last part they classified the extreme event which is having return period of more than 100 years. So this is one of the classification, and in this slide we will discuss the flood impacts. So as we discussed, there are basically two types of impacts: the tangible direct impacts. So in this there are damages occurred to the buildings, infrastructure such as roads, bridge, healthcare system, post offices, school buildings, or damages occurred to the crops, tools, or livestock. So these are the tangible direct losses. Also, there can be a damages which can be caused by the fire, which is started because of the flood. Also, damages caused by the crops and lands by contamination of soil by seawater. Then damages caused by the electricity cuts to the machines and computers. Then flood brings deterioration and decay of the property. So this can be converted into the damage. Then there are long-term rot and dams, weakened infrastructure, more damages prone to the further flooding or disaster. So these are the tangible direct losses. There are intangible indirect losses. For example, there can be a loss of agricultural or industrial production, There can be the loss or disruption of the public transportation, the loss of healthcare system and education system, then loss of the utility supplies. Then the flood can bring a contamination of water supplies, then food supply shortages, food chain disruption, loss of income, increased household cost, and it can also result in the price inflation. So because of the flood, some businesses become bankrupt, they lost their investment. So this is also one of the loss, and there can be a disruption of the employee flow at work. So loss of exports. So there are, because of the disruption in the business cycle, there can be loss of export, and ultimately these will affect the national gross domestic product of the state. On the other side, there are the intangible human losses which cannot be counted in terms of money. So for example, loss of life or physical injury or loss of heritage or archaeological sites. So this can be also resulted because of the flood. Then flood can bring increased stress, physical and psychological traumas, increase of waterborne diseases, increase in the health hazard situation, and there can be an increased mortality and morbidity. This can also bring social consequences such as homelessness, displacement of population, increased vulnerability to further shocks, and disruption of the communities. So there are the wider damages because of the flood. So after understanding this, we will understand why really flood occurs. So as we discussed in the one of the slide, there are two important reasons for the flood. First is the inflow discharge, and second is the flow constraint. So what includes in the inflow discharge is, as we discussed, it is a flood is caused because of the heavy rain, because of the melting of ice, because of the landslide, tsunami, or dam break. And if there is a sufficient waterway available in the river, then flooding will not occur. But if river characteristics are narrower, there are encroachments in the river, then if there are a flow constraint, then upcoming flow cannot be accommodated within the boundaries of river, and it will cause a flooding of the low-lying areas. And if there is a debris or suspended solids in the water, it also causes sedimentation, and because of the sedimentation, the flowing capacity of the river decreases, and it will also impacts or enhances the risk of flooding. So flood damages, as we discussed in the tsunami case, basically flood causes damages because of the two reasons. First reason is that the damages because of the standing water. So these damages include soaking, dissolution, or ground unstable or muddy, and damages caused because of the drowning. And more than 75% of the deaths occur because of the drowning in the standing water. And there are the damages because of the rushing water. So water crashing into the building, cars, and other things, which also cause a damage. And it is a well-known fact that if there is a only 15 centimeter depth of fast moving water, it can knock a person off your feet. And if the depth of water is just 40 centimeter, then it can carry any automobile. So you can imagine that a flowing water has an intense power. It can wash away the automobiles or cars or bus, and often people get killed because of the rushing water. Now we will discuss our topic, that is the urban flooding. This is the second part of my presentation, and in this part we will discuss why urban flooding will be much more difficult to manage. So urban flooding is caused because of the river flooding, the flooding because of the free catchment. There can be a stagnant water, and urban flood management becomes very difficult in case incoming runoff is difficult to manage. So in order to have good urban flood management, we should have detention storages. These detention storage will increase travel time of the water, and minimize the peak discharge. Then we can use rainwater harvesting. So the discharge coming to the river stream will be decreased because of this. There can be the green groups. So such type of green groups can be implemented. So which will absorb some quantum of water, and thus discharge peak can be reduced. So there can be a mechanism of increasing the infiltration in the ground. So we can have proper urban planning so that there will be less cementitious cover on the ground, and there will be the more greenery on the ground, which will enhance the filtration rate. So water will not flow on the roads or on the footpath. So water will be filtrated or infiltrated in the soil. This will reduce runoff, and there are various technologies available in order to increase the rate of infiltration. It can be percolated on the ground or between below the ground, and this water can be drained out. So this will avoid the stagnation of the standing water. So in this part we will discuss how IoT will help in the flood management. So tools of IoT are very useful for managing three activities of flood. First, there are some activities which should be managed before occurrence of the flood. So this is a preparedness stage. So at preparedness stage, IoT can be useful in order to make land use and watershed mapping. As we discussed, tools of GIS are very useful. Then in order to get weather information parameters, the IoT is very useful. We can also get reservoir, dam or river information with IoT. Then we can have data acquisition system, that is the DAS, data acquisition system, and modeling. Using this information, we can have emergency action plan, that is EAP, and ultimately we can showcase this data using tools of IoT and tools of GIS. So and dissemination of this data. The second phase, during flood. So there are some activities which are required to be carried out during flood event, and this most important activity is real-time decision support system. So whatever quantum of rainfall falling on the ground, what is the quantum of runoff, what is the present river level, what is the present dam level, what will be the releases from the dam. So all this information is summarized. Then river water carrying capacity of the river is anticipated, and if upcoming water discharge is more than the carrying capacity of river, then we can have a flood. So real-time decision support system helps a decision maker in order to get all the data and in order to get a response from the system that this can be a optimum decision or most favorable decision to take. So this system helps a decision maker in order to start the releases from dam or in order to implement the evacuation plan. So if there is a large area flooding, decision maker can plan the critical area for evacuation. So he can make a priority list of the evacuation. Second important activity which can be implemented using IoT is weather forecasting and warnings. So if there is a flooding happening today in certain area, and if there is a warning about the high level flood, then in order to disseminate this warning or in order to get the forecast itself, we can use the IoT. Then information broadcasting, it is very important communication within and outside the organization, and ultimately evacuation plan. The last is a after flood. So after flood, it is utmost important to assess the damages caused because of the flood, and if there are crop damages, so these damages can be measured for the insurance purpose, and these damages can be assessed through tools of IoT such as drones, remote sensing satellite imageries, and we can using the before flood data, during flood data, we can uh, formulate coping strategy for upcoming flood, and we can update our model if there are lacunas. So urban flooding is a development challenge, and this urban flooding causes devastation, economic loss, and loss of the life, uh, and it also cause a adverse impact to the ecology. And due to the urbanization and possibility of the climate change, the risk of urban flooding has been increased. So, 2008 was the first year in which in the human history in which 50% of the world population lived in the urban area, and two-thirds of the urban population falls in low income and middle income nations. And it is estimated that by year 2030 about 60% population will be urban, and it is also estimated that by the year 2050 about 70% population will be the urban, and hence urban flooding will hamper more population in future. And how this urban flooding is different than the rural flooding we'll discuss in 2 minutes. So urban flooding and rural flooding both causes damages to life and property, but economic damages are much higher in urban area. The depletion of the flood water in urban areas takes time due to the construction activities and infrastructure. The population density in urban settlement is very high as compared to the rural settlement. Hence, this area is prone to more damages to life. And during development, most of the natural streams are buried, damaged, disturbed. Hence, drainage becomes a major issue. Many times, rainfall volumes becomes a runoff discharge, and in this situation, it becomes a challenge for flood mitigation. The if flash flood occurs in case of retaining wall fails in urban area or in case of embankment fails, then it can cause more damages due to sudden inflow of water. Damages will be more in the slum area as there are poor protection infrastructure, and these area generally reside at the lower level elevation, and which is very vulnerable to the flood risk. There are other factors which affect the urban flooding. For example, in urban area, most of the area is paved. For example, a road area, footpath area, or building area, it is a paved area. So infiltration of water in the soil is low. There is a overcrowding. Sometimes there is an unplanned urbanization. There can be a choking of drainage due to the poor solid waste management, and filling of the low-lying areas in order to construct buildings or roads, and lastly over extraction of the groundwater, which can lead subsidence of the soil, and lack of the flood risk management activities. So I will because of time constraint I will skip some of the slides, and so I will jump to the way ahead. This is the last part of my presentation, and I will discuss what are the possibilities for the future. So most important thing is flood early warning system. So we can digitize historical database of the rainfall, runoff, river system, its topography, and this data can be coupled with the drainage basin database, that is digital elevation model of the terrain. If we combine these two data and if we have real-time rainfall data, then we can have flood model, and this flood model can help us in order to prepare flood maps, and these flood maps can give a flood alerts. So this flood early warning system will help the administration as well as communities in order to better prepare for the flood and minimize its adverse impact. So in the first one of the slide we discuss about the vulnerability and the flood vulnerability, hazard, and its potential. So in order to avoid a disaster, it is utmost important to first try to prevent the flood. If it is not possible to prevent the disaster, then at least have preparedness in order to mitigate its adverse impact. So disaster mitigation strategies can be evolved with the help of tools of IoT, and flood forecasting is can be achieved through reliable advanced information about the impending floods. Flood inundation mapping and land use planning can be done using satellite remote sensing or drones for monitoring the dynamics of water spread. And last is a decision support system for real-time flood warning and management. So if we have these three tools, that is flood forecasting, flood inundation mapping, and decision support system for real-time flood warning and management. So if we have these three tools, then our flood mitigation becomes much more handy and uh, sustainable. And this is the last slide of my presentation. So what is the way ahead? What are the challenges? First challenge is more population will be in urban areas, and urban population is vulnerable to the floods. Flood damages are higher in the urban areas as compared to the rural area, and there are after effects. So it is not like that if flood happens, there are the instantaneous damages. There can be a instantaneous damages as well as after effect damages. Effective planning and management of the flood is necessary. It is utmost important to monitor the flood lines, and it shall be regulated in order to avoid encroachment in the river stream. A relief flood warning system and flood management plan shall be prepared, and tools of IoT will help in order to do the same. The climate change will worsen the situation, and hence attention shall be given for mitigating the urban flooding impacts. And last but not the least, IoT will help planner and community at large to have data acquisition system and decision support system and a communication network, which will help flood management and which can save lives and property. That's all from my side. Thank you very much.
Yeah, if at all there is any question from student side, you can ask the question. Even you can put in the chat box if there is any problem for delivering the question. Yes, is there any student wish to ask any question, any doubt? Bhavya, Dhruv Chauhan, am I audible to you, Dhruv?
Yes, sir.
Yeah, is there any question from your side?
Yes, sir. Just a minute.
Meanwhile, even we can take a question from any other student. So as Dhruv wished to ask the question, before that actually I would just share a few things with Mr. Praveen sir. This is the class of IoT for smart cities. These are the third year students. In third year, actually we have floated honors this time. So in honors, IoT for smart cities is one of the subject. There are around 15 to 16 students who have registered for this particular course, and under this course actually we have planned your lecture. It was very good session, but before going for the vote of thanks, actually, yes, Dhruv has raised his hand. Yes, Dhruv.
Yes, sir. So thank you, sir, for the amazing session. I just wanted to ask a question that after the flood, during the flood, what is the way through which we clear the water using the IoT system?
Yeah. So it is. Have you seen any flooded river? Have you seen?
Not in real life, sir, but in videos I have seen, sir.
Okay. So in real life, we cannot manage flood water using any tool because volume of incoming water is so large that it is not possible to lift that water or force that water to move away. So as of now, there is a no tool which can help us to mitigate the flood water. So generally what happens, flood is a natural phenomena, and flooding occurs because of the as we discussed, the carrying capacity, limitation of the carrying capacity of the river. And if slope of the area is very gentle, that is the terrain is flat, then what happens, it takes a time for uh, draining of all the water. So as of now, there is a no tool for draining out the water from the flooded area, and this drainage happens as soon as water gets chance to drain out. So yeah, a simple answer to your question is there is no tool for is accelerating the drainage.
Yes. Yeah. So basically, why we are using the IoT here, so that we can manage the risk. Basically, we can avoid the risk. So as Mr. Praveen has mentioned a few points, like we can give the priority for evacuation the people from that particular area, so that we can manage the risk basically. So rescue operation we can do easily with the help of these tools. Yes.
Yeah, but though it is a very good question, and I just want to supplement my answer that in some cities like in Mumbai, because elevation of Mumbai is very near to the sea surface. So what happens if this drain water is not discharged in the sea, then it causes stagnation of water. So in a city like Mumbai, what they had constructed a low level lift schemes. So flood water is literally lifted through a pump system and it is a discharge into the sea level. In city like Chennai, this also happen, and if there is a low lying area, this there is a no alternative. So in order to extrapolate your thought, this is really very innovative and interesting question you asked, and you can explore these systems which are executed in Mumbai. And as we discuss in our today's presentation, that because of the climate change, sea water level will rise, and because of this, drainage in the coastal cities becomes a challenge. So how mechanically we can push the flood water in a sea is a challenge, and you can work on this as a project or research topic. You can take this as a research topic, and you can suggest some strategies how IoT can help a planner or decision maker in order to accelerate the drainage near the coastal cities. Okay,
Yeah.
thank
Sure,
you.
sir. Thank you, sir. Thank you, sir.
Thank you, sir. Is there any question? Any other question? Okay. Yes.
Sir, I think it's posted some question on the chat box.
Okay. Okay. Yeah. I'll just go to the chat box. Okay. Yeah. So Anmol has posted the question. To what extent does human activities cause or affect flooding?
Yeah, Anmol, this is also interesting question. So there is no straightforward answer for this question, because as we discussed, the flood happened in an area where there is a no population, human population. So there might not be a human activity, but there is a flooding. And on the other hand, there is a flooding only because of the manual human activities. For example, breach of dam. If a reservoir or dam failed, then it can cause a intense flooding. So there are two extremes. On one side, the human is not possible for flooding, and on other side, the 100% contribution is given by the human for the flooding. But now there is a third dimension, that is the climate change, and because it has there is a theory that climate change is a human induced phenomena. And if we accept this assumption, then we can say that flood is caused because of the intense rainfall at a very short time at a smaller geographical area. And if splash flood happens, if these splash floods are caused because of the climate change, we can say that it is a human induced floods. So we can say that earlier period, The floods were caused because of the either man-made activity or by the natural phenomena. But in present situation, we can say that flood is caused because of the combination of these two activities. Hope I answered your query.
Yeah, sure. Okay, so if there is any other question, even we can take one question. Okay. So yeah, I could not see any question in the chat box. So I think we can wind up the session. Thank you, Praveen sir, for delivering the session. Actually, though you are very much busy, there are around more than 600 people working under him, and in spite of this busy schedule, actually, he could spend time for delivering the talk for us. Even I would like you to interact with our students actually physically, because all the students could not come to the college. Only few students who are part of a particular project, they are coming and working physically here. Otherwise, all the students are attending the sessions online only. So once they would join the Symbiosis again physically, so I would like you to invite for a particular session. There are around more than 10 students actually who are interested for attempting GATE exam. This is the batch from whom actually I expect more number of GATE rankers. Generally in the Symbiosis, one or two students crack the GATE exam, but this is the batch 1923 batch whom I expect that more number of GATE rankers would be there, and they would definitely go through your website, and definitely they would get the motivation from you. So thank you, sir. Thanks for your time.
Yeah, thank you for inviting. I will definitely be there. Yeah, thank you.
Yeah.
Thank
Thank
you,
you.
Best.
sir. Thank you, sir.
Thank you. Okay.